Hi everyone, today we'll be learning about MOSFET, that is metal oxide semiconductor field effect transistor. So one practically used MOSFET, that is IRF 640. So when we are learning about this MOSFET, just we will see the data sheet of IRF 640. So it can be downloaded from alldatasheet.com. So their IRF 640, here we can see the symbol of IRF 640. It is having three terminals, that is drain, source and gate. MOSFET normally it is a high frequency, low power device. It is not used for switching circuits. So we'll be using this data sheet, its electrical characteristics for designing the switching circuit or any other circuits with IRF 640. So like IRF 640, IRF Z45 is there, Z44 is there. Depending upon the application, we can use the different types of MOSFET. So before that, why this MOSFET is called as metal oxide semiconductor? So we can take an example of any one MOSFET, its layer diagram. In a MOSFET, substrate will be there. It can be either P or N. Now I am taking P. So we have seen three terminals, right? Drain, source, and gate. So I'm taking here. This is your source connection. This can be drain. Now we'll come why it is called as MOS, metal oxide semiconductor. So here one semiconductor material is there, right? In that we'll be having one small silicon dioxide layer, SiO2. So this is your SiO2 layer, silicon dioxide. Above that we'll be having a metal layer. So here one semiconductor layer is there. That can be either P or N. One silicon dioxide layer is there. Then one metal layer is there. Metal oxide semiconductor. That's why it is called as MOS, metal oxide semiconductor field effect transistor. Normally it is used as a switch. It is a high frequency, low power device. Normally it is used for switching applications, high frequency applications. Next, we will see the classification. How it is being classified. The MOSFET, it is widely classified to two categories, that is depletion type MOSFET and enhancement type MOSFET. Depletion mode and enhancement mode. So we have seen that data sheet, right? That was whether it is depletion or enhancement. You can see it here. It is an enhancement type MOSFET. So what is depletion? What is enhancement? Depletion type MOSFET means already channel will be present. Channel will be present inside the structure. So in the case of enhancement, there is no channel. We need to create the channel. by applying voltage. So inside depletion, again, it can be classified to P channel and N channel. Again, enhancement also, it can be classified to P channel and N channel. So what is this channel? Present, channel not present, we may get confused, right? So here we can see between this source and drain, there is no channel. Nothing is there between this source and drain. Suppose there is a channel inbuilt. There is an N minus channel inbuilt between this source and drain. We can tell it as a depletion type. Channel is not present, enhancement. Channel is present means it is depletion. So this is now a depletion type MOSFET. So for learning the working, we take an example of N channel. That is our IRF 640 itself we will take. That is N channel enhancement type MOSFET. How it is been working. When you're taking an N-channel enhancement type MOSFET, the substrate should be P. Just opposite of the channel. The drain region and source region. That will be N plus. N plus source and N plus drain. So this is source. This is drain. So gate connection, we will take one silicon dioxide layer is there. Above that one, metal layer is there. That gate connection will be taken. As it is enhancement, no channel is present right here. So how we can create the channel? So we need to apply voltage to gate. And biasing needs to be provided to across source and gate. So we are told MOSFET it is having three terminals, drain, gate and source. But actually one more terminal will be there, that is body. Normally it is not shown outside, it will be shorted with your source. That is an internal connection. The source connection can be negative and the positive with respect to gate. Same way, source is negative with respect to drain. So when I'm giving a positive voltage at gate, what will happen here? Positive voltage is being given here. So unlike poles always attract, so the electrons from this P substrate, that is minority carriers. This is a P substrate. P substrate means it will be having majority carriers as holes and minority carriers as electrons. So when I'm applying this positive, this minority carriers, it will attract this minority electrons towards this gate. So here it is just like a inter-electrode capacitance effect. This is a most capacitor actually. So because of this capacitance effect, two plates are there. Here one metal plate is there. Here one semiconductor plate is there. In between, one silicon dioxide layer is there. So one plate of this metal. This plate is positive means it will attract electrons and this plate will be negative. So we can see here an N channel is being created. So through this N channel, the conduction will happen. So whenever there is a N and P type, in diode itself we are seeing N and P type, in between one depletion layer will be formed. So here also a depletion layer will be there. So as we have created this channel and we are applying drain voltage, some changes will happen here that we will see in this VI characteristics of MOSFET.